was sending text messages throughout the day until 10 to 8 of the 17th of January. So one of the questions that was key in the investigation was it actually Amanda who was sending text messages from her phone, or perhaps the police suspected her husband actually. So what you see here is the analysis that was done by the forensic linguist who worked on this case, Professor Tim Grant at Ulster University. So he identified a set of features that were used by Amanda Burks and a set of features that were used by Christopher Burke. And so as you can see here in blue, for example, there are some features that Amanda Burke used consistently in her text messages and that Christopher Burke didn't do. But of course, because they were husband and wives, there was a set of shared features that both of them used. So for example, the one at the bottom, like W for with, those were features that were predominantly used by Amanda, but with some use from Christopher. Now, what you see here, for example, is these are text messages that were sent from Christopher Burke's phone on the 16th of January. And you can see all of the features highlighted in red, as well as the when for when without H at the end, which is something that both of them did. Now, it's important to bear in mind that at that time, 2009, this is before smartphones were actually common, and most of us were saving words and had to find ways to acronyms and short forms in order to save space. So this is why you see so much creativity. So this is an example of messages sent from Christopher Burke's phone. And then these are the ones that are sent from Amanda Burke's phone, again, on the 16th of January 2009, which is the day before the house fire. So what you see here is that all of these text messages, you find features that Amanda Burke uses frequently. Then on the following day, on the 17th, around 12 o'clock, you see something odd, which is the appearance of this 4A, which is something that Amanda never did. And then you start to see the use of commas below, which are, again, things that Amanda Burke rarely used, and they were more characteristic of Christopher Burke's texting style. Then, as text messages later in the day of the 17th are examined, it becomes more and more clear that this was not Amanda because of all of these features that were actually used by Christopher Burks. And this is, of course, until the end of the day when the house fire happened. And so this evidence was used, was presented in court and was used to, as part of the evidence to convict Christopher Burke for the murder of her wife, Amanda. And this is one of the rare cases, actually, where linguistics was used also to estimate sort of time of death, because there's some probability that just the day before, the phone was already in the hands of Christopher Burke. Now, so what you've seen here is an example of a authorship analysis case where linguistics was used, and there are many others, of course. This is from 2009. Since then, there have been several cases where forensic linguists have testified. But I just use that as an example. Again, if you're not familiar with this particular field of applied linguistics. So when we consider these cases of identifying individuals through the way they use their language, one thing that one of the things that come particularly often, for example, in the media, when the media describe these cases is that perhaps we all have a linguistic fingerprint. So something like DNA or a fingerprint, something that identifies us as individuals, and it is only constituted by linguistic features. And although it's a useful metaphor, it's also a kind of misleading metaphor as well, because there are at least two crucial differences between a linguistic fingerprint, if you will, and a real fingerprint. And one is that a linguistic fingerprint, if it exists, it cannot be fully quantified. And by that, I mean that if I take a fingerprint from one of your fingers, then I have the complete picture of that. But if I take any sample of language from you, that would never be the total set of all your utterances or possible utterances. The other thing is that in contrast with a real fingerprint, a linguistic fingerprint would constantly evolve and change. So the language you speak is not the same, that the language you speak right now is not the same language you were speaking a few years after you were born, and you constantly learn new words and new grammatical constructions. So it's something that is dynamic. However, one concept that comes back very often in forensic linguistics is the one of idiolect, meaning our own personal variety of language. And it's something that linguistics has not studied in depth. And this is because traditionally linguistics was mostly focused on finding commonalities, as opposed to finding why individuals should be different from each other. Most of the field was focused on finding what is in common between individuals, and in order to study language as a wide community phenomenon. Instead, what forensic linguists need actually is precisely the opposite of that. So we have to have a better understanding of what makes all of us linguistically different individuals. And to the extent that these individual differences are large, then this means that we can do this type of work of identifying people from the language they use. And we don't know a lot about idiolect. That's the problem, really. Now, one thing that we know is that, at least from a theoretical perspective, the combinatorics of language are susceptible to this kind of variation, should be. So, for example, what you see here, this is taken from McManaman's Forensic Linguistics textbook. These are all signs that he found on the road that were marking stands that were selling strawberries. Now, this is a very simple message, right? So the message is, here you can buy strawberries. And yet you find that there is a massive amount of variation, even in that. So actually, none of these signs are the same. They're all different. Although if you are actually looking very carefully, you will notice that two of them are the same. But this is because it's the same person. So it's the sign on two different directions of the same road. So if we think about why do we find all of this variation, well, let's look at the possible choices here, right? So we have spelling, so you can spell berry in the different ways, morphology, variation, word formation, positioning, and we can add many others. So this is just a sample, right? So when you combine all of these possible choices, then the resulting possibilities is such a large number that, at least theoretically, you would expect, all things being equal, that there is a lot of variation. Now, we still don't know, though, why we would be so different, right? So why would we choose differently? And this is a different question, but at least in terms of the range of possibilities, it's something that makes sense. Now, the powerful combinatorics of language became evident in a particularly famous case, the one of the Unabomber. This happened, all of these events happened in the United States in the 80s and 90s, where these bombs over here were sent to universities and airlines, and this is where the name Unabomber comes from. And the Unabomber was sending letters to newspapers, and at some point sent a 35,000 word manifesto. And at that moment, the FBI, so there was a massive manhunt for the Unabomber, and the FBI was without any clues. So what they decided to do was to accept the request of the Unabomber to publish this manifesto, which they did. And they were hoping for someone to recognize the language in this manifesto. And this manifesto was, some of the things that appear in this manifesto were phrases like cool-headed logician, or the idiom, you can't eat your cake and have it too, which is kind of the reverse of the most frequent way of phrasing that. And what happened was that indeed, the brother of the Unabomber recognized the language and contacted the FBI, and that led to a search warrant that eventually led to the arrest of Ted Kaczynski, who was actually a professor of mathematics. Now, forensic linguistics didn't play a part in the arrest of the Unabomber. So what actually happened was what I just described. So it was his brother who recognized the language, but language didn't play a part in this. Forensic linguistics, though, remembers this case because of what happened after the arrest. So there was a lot of evidence, of course, to convict Ted Kaczynski, because once they had the search warrant to inspect his cabin, they found all the bombs and everything. So there was no question. But Kaczynski challenged the search warrant because one FBI agent who was not trained in linguistics did a linguistic analysis comparing his known writings and the manifesto and the letters. And what he found was that there were similarities in terms of these certain linguistic features that were in common between the sets of writings, known writings, written by Ted Kaczynski and the manifesto. So things like what you see here, at any rate, clearly, more or less, on the other hand. And his challenge was that any speaker of English can use these phrases or words. So there's nothing distinctive in using this particular set of features. However, at the time, the counter argument of the FBI was to search all of them on Google, which returned only 69 hits, which were all copies of the manifesto. So in other words, what you see here is, in a certain way, it's a fingerprint of the manifesto that is shared between Ted Kaczynski and those writings. So of course, it's metaphorically, only metaphorically speaking, we can say that it's a fingerprint. But the powerful thing here, nonetheless, is that this combinatorics of language, it increases the number of possibilities to such extent that you can have a sort of linguistic identity. Okay, so it points to that possibility. Now, attributing texts is not something new, and it's not something that comes from forensic linguistics. It's actually probably thousands of years old. There is evidence of authorship attribution in ancient Greece. And it's a field that was mostly, there's been developed by literary scholars. So if you think about, say, attributing a particular play to Shakespeare or Marlowe, in the 19th century, a scholar called Mendenhall precisely addressed this question and used average word lengths to compare texts. And the hope was that something like average word lengths would be an author invariance, would be something that each of us has in its own way, in our own way, that is unique, that can identify us no matter what we write. And just imagine just doing that without a computer, by the way. So collecting all of these, all of these works and then going through them and do this analysis manually. However, none of this works. So we now know after hundreds of years that there isn't a particular feature that will identify us in a way that we can attribute text. But by doing that, Medenow started the field of stylometry, which is the field that investigates style, especially author style, using computers, using quantitative methods. And so that for many years, there wasn't any sort of breakthrough until two statisticians, Mosler and Wallace, in the 60s, came to tackle this problem of the Federalist papers. The Federalist papers were essays connected to the American Constitution. They were anonymous originally, but there was a set of them that was disputed between these two authors, Alexander Hamilton and James Madison. And Mosler and Wallace, they were not linguists, they were not literary scholars, they were statisticians. And so coming from that perspective, they decided to look at word frequency. So this comes from their paper. So what they say is that we will look at word counts, but because we know that topic influences word counts, then we will use the filler words of the language, such as and, of, upon, and articles. And this is because they have fairly stable counts. So they occur with a frequency that is reliable. And from the point of view of a statistician, of course, that's what you want to do. You want to count reliably. And they have the additional value that they do not depend on topic. So in other words, what they did is, if you imagine this as a text, as a toy text, you essentially transform it into a bag of words, and then it becomes a problem like similarly to a bag of marbles. And what is the probability of extracting, say, a red ball? Similarly, what is the probability that a certain author will use the or on, and so on? So once they have their own, the two candidate authors with their own writings, the disputed text, then you have all of these function words, that's what we call them nowadays. Then we can say, okay, Hamilton actually likes upon, and Madison likes to use also. And mathematically speaking, what you're doing here is relatively simple. So you're taking, let's imagine that this axis, the vertical axis, is the frequency of upon, right? So the higher you go, the more frequently you use it, and same with also. Then you can say, okay, this is the position of author A, and this is the position in this space of author B, and what is their distance? Of course, you don't have two words, you have possibly thousands of words, okay? But the principle is the same. So you look at the distance between authors in this space, and then you take your disputed text, and you say, okay, what is the distance between this disputed text and the authors, and which one is closer? So, and this is since the 60s, really. This is the way that we do authorship attribution nowadays. It's not super complicated. Of course, you can't do it manually because it requires a lot of computation. We use computers for that. But conceptually, it all boils down to this. And the question that I'm addressing, though, is how can this make any linguistic sense, if you think about it? Okay, so for example, we can say that in principle, this is based on an inaccurate model of language, of how language works. So the assumptions of this method is that whenever we use words, we sample them from this bag of marbles, right? And this is clearly wrong. We don't do that. And also, it's disputable that words are the unit of language anyway. So we don't select one word and then we select another word after that. It's also based on an inaccurate model of individuality, because if one of these authors uses upon more frequently, can we say that it is because they like these words? Is that the reason why they do that? I mean, possibly there are certain words that we use more often because we like them, but that cannot be the only reason that explains the success of these methods. So clearly there has to be an understanding of what leads to certain author using certain words more frequently than others, and it cannot just be preference. But as I said, it works. So we know that provided enough data is collected, we can do this type of work. So we have to find a way to explain it. And this is basically my research agenda in the recent years. Now, to begin with, so I will now describe my perspective here and the kind of theory that I think is needed to make sense of all of this. And I will begin with a quote from Martin Haspelmann's blog. It's a blog post that is called something like "We Are All Constructionists," or a similar title. So what he says is that linguists have different temperaments. Some want maximal generality at the expense of cutting some corners, and others want maximal attention to detail at the expense of a big picture. And he, I mean, this debate is kind of has prototypically, let's say, generative grammar on one end and construction, functional, usage-based models on the other end. And I like how he puts it, that you're cutting some corners. I think that forensic linguistics cannot really afford to cut corners. So in between these two ends of the decline of linguistic theory, I think a theory that would make sense for forensic linguistics is really something that is more on the usage-based line. So I will be referring to usage-based frameworks here. And of course, there is a sort of variety of different types of usage-based frameworks. The two, say, core, the fundamentals of usage-based frameworks could be the famous position paper by Beckner et al., Language is a Complex Adapted System, or more recently, Goldberg in 2019 published in her latest monograph, the sense me principle. So if we want to boil this down to something easier, just a summary, especially as relevant to this type of work, that I am proposing, is that individual's language is a network of constructions. They are connected to each other, and that comes out of usage, especially from clustering of memory instances of real language use. So it's usage-based in the sense that usage is what leads to the creation of our language network. So I'll go over some of these. So this is called cognitive linguistics. I adopt this label. And there are some tenets of cognitive linguistics. There are different flavors of cognitive linguistics, really. And I'll but I think I can list some basic axioms. Let's say we take them as axioms for the rest of the talk at least. So, for example, the language is a network of knowledge. This is something that is relatively undisputed within the umbrella term of cognitive linguistics. Memory of exemplars is important, so we have a rich memory of actual instances of language use. These traces of exemplars, they combine and they to the extent that they reach some critical thresholds, they become constructions. And words are not the unit of grammar, but constructions are. And there is no distinction between lexis and grammar. There is only one lexical grammar, because lexis and grammar are actually two ends of the same thing, of the same climb. So we can represent grammar, in essence, as a constructicon, which can be modeled like a lexicon. So all of these things are more or less, a lot of frameworks like Halliday's Systemic Functional Grammar, Ivey, Goldberg, Michael Hoy, Hudson, Croft, all of them more or less share this particular view of language. And we can also say that all of these things are actually, what they imply is that memory plays a much bigger role than we originally thought, which is a conclusion that we can draw even from corpus linguistics findings, recent corpus linguistic findings, and as well as experimental findings in cognitive science and psycholinguistics. So starting from this point, so let's assume that all of this is correct, then we can start to propose a theory of individuality, which is what I'm trying to do with my recent work. So if lexical grammar is a network of knowledge of grammar, then we can say that we can represent it as such. So we can represent it as a network, which is a network, or a graph is a mathematical object. So we can talk, we can treat it in that way. So we can imagine the grammar of a person A as GA. And remember, by grammar here, I mean constructicon. So words are also constructions. So hope is a word and it's a construction, but so is, on the other hand, comma, which could be a construction. So at the beginning of a sentence, for example, a prepositional phrase using prepositional and a noun followed by a noun is also a construction, and a generalization of, on the other hand, comma could be adverb, again, as the beginning of a sentence, and things that are in between as well can be construction. So the noun of, including morphemes. Morphemes also can be considered construction. So noun less as a morpheme. Now, all of this is not knowledge that is, in the left on its own, but as I said, this belongs, it's all connected in a network. So, for example, the fact that these two things are related have to be present in our knowledge of language, in our constructicon. So there is a relationship of inheritance here. But also, hand is a noun, right? So it will be connected to this kind of representation, and so is of as a preposition, and also on as part of the on the other hand. Okay, so we can construct this network, and as I said, if we treat this as a network, we can treat it as a mathematical object, because a network is really just a set of edges and a set of connections. However, so this would be the ideal way of representing formally our constructicon, but it's quite difficult to do that, because we don't really have the tools to examine, to extract a representation of this kind computationally, for example, from text. So in order to simplify, what we can do for now, at least, is remove all of the connections and just treat this as a set. So we can represent a constructicon, in other words, as the set of constructions that a person knows. Well, let's stay with that for now. Now, there is a crucial difference between what I showed you before and this type of representation, because if we take that toy text as before, that was a bag, okay, so similar to this type of bag, and this is a set. So the set does not allow even these are two mathematical terms, right? So a bag contained allows repetition and a set does not. So we are not talking about how many times something occurs. We are only talking about knowledge, whether someone knows a particular form or not, which is actually what a forensic linguist wants to understand. Now we can think of a way to transform this bag, which I'm indicating with square brackets, into a particular set. We can use a function. For example, we can say that all of the words or all of the constructions in this bag that occur at least once will be a set, will be part of that set, or it could be all of those words that occur 2 times or 3 times. It's so this kind of threshold. In other words, what I'm trying to say is that we have to discover what is the threshold after which we can confidently say that a particular person using a particular construction in the text actually know that construction. And it's an empirical question, of course, but the point of setting out this theory is precisely to put it in a form that we can discuss. So we need to understand this particular aspect of the theory. But going back to, let's assume we can do that. Let's assume that we can just take all of the words that occur at least once as members of this set, and we can go back to our grammar. Okay, so this is how we would represent the grammar of a person, but there's one missing detail here, which is that this is only a grammar of a person at a precise point in time t. And this is because, as I said before, the difference between any linguistic fingerprint, which is what I'm trying to model here in a way, and a real fingerprint is the fact that the linguistic fingerprint would change over time. So we have to have a system that takes that into account. So we can only, whenever we draw a set, we talk about a set, it's always a set embedded in a particular instance of time t. And it is still a kind of simplified picture because, of course, now I'm talking about grammar, knowledge of grammar, but actually in reality we have different types of knowledge of grammar. At least we have a passive knowledge of grammar and an active knowledge of grammar, where the active is always a subset of the passive. So what I'm trying to say here is that we know much more constructions than what we produce. We understand things, but we don't use them. And so similarly, this reflects what we know about the lexicon. So we know many more words than the words that we actually use. And it's something that is not very well investigated, even in the lexicon. But in particular for construction, it's something that it's probably unaddressed. So a lot of research has to go into this particular aspect. And we have to also understand that, okay, we can call, so we call the active AG, the passive PG, but actually because AG is always a subset of PG, just when we say grammar, we mean passive. We also have to, I mean, it's probably the case that these borders are not set, they're not very strong borders. So it's probably a climb. There is a certain probability that you can or want to use a certain form or not. And the important thing for us really is to understand how and why we do that. But for now, in terms of theoretical perspective, we have to recognize this difference between AG and PG. So, so if we have this picture of an individual's grammar, another thing that we have to state is that this is not the end of the story, because of course this grammar, this particular, if we just single out the active grammar of a person, must be embedded in a language. And what we define by language is all the other constructions that are not part of the active grammar of that particular individual at time t. I just noticed that the L also has a small t. So a language is always changing as well. So we can only talk about a particular instance or a particular moment in time of a language. So by representing all of these aspects of the theory in this way, we can start to make some claims. Oh, sorry, forgot. So if we have another individual, okay, the individual B, then we can talk about the overlap between these two sets as what they have in common. And we can also talk about, but I would say that more formally now in the next slide. So once we have all of these tools, what we can say, we can make some statements. So for example, we can define the idiolect. At least, again, I'm talking about just lexical grammar here. I'm not talking about phonetic features, for example. I would not be dealing with that. But in terms of lexical grammar, we can talk about the idiolect of a particular person A as the union of all of the grammars at different points in time. And it's the union, not the addition, because we assume that, I mean, we don't repeat constructions that are already present. So if you know it, it will just stay with you, or at least we assume that. We can also define a language at a particular point in time T as the union of all of the grammars of all of the individuals in a particular area, for example, at that particular time T. So in other words, the superset there is the universe. It's the universe of all the possibilities. And then the other thing we can say is that we can also talk about a language in general as the union of all the idiolects, which again is probably relatively non-controversial. Now, this is just the beginning of what one can develop, because there are unanswered questions here. For example, how do you account for loss? This is something that I haven't really thought about a solution for. So for example, is it, if we acquire a construction in our constructicon, do we also lose it? Can we lose it? I mean, we almost certainly do. There are lots of constructions that we used when we were young, and now we don't anymore. So it's not that once something belongs to a set and will stay there forever. It can also change, right? So it can also be removed, and that's something that I have to work out. Okay, so with these tools, what we can say is that we can start to talk about how to study things in terms of to understand idiolect. So we can propose, for example, that all of forensic linguistics and authorship analysis is based on the principle of linguistic individuality, which is that for each grammar belonging to a certain individual at a certain point in time that belongs to a language at a particular moment in time, there's no other grammar that is identical. So this is it must be an assumption of authorship analysis, because if this is false, or to the extent that this is false, then we cannot really recognize individuals, or it would be more questionable. But I think this is something that is relatively uncontroversial, independently of what kind of branch of linguistics you come from. So we kind of, even in generative grammar, I believe, it is assumed that there are idiolects, and that these idiolects are all different. But there aren't enough studies on that. And this is, again, probably because linguistics focused on commonalities as opposed to differences. Now, usage-based frameworks predict this type of endpoint for language, because if we have individuals and we track their paths in their lives, then they will learn their constructicon from usage. And usage means that if groups of individuals that have different life experiences will end up with slightly different grammar. Now, because no two individuals, arguably, do exactly the same thing, then out of necessity, it derives that they will have different grammars. And here I'm not even considering those cognitive differences that will alter the perception of the same text, right? So even if two individuals were to be exposed to the same output, they will still perhaps come up with different representations. But as I said, there aren't enough studies on this particular topic. Now, one that is So different life experiences, different texts, different exemplars, different grammar. One important study that has not been replicated enough is Mollin's study of Tony Blair's language. She took 3 million words of interviews, speeches, and all of that. And she looked at only one feature, which is the use of maximizers with adjectives or verbs. And she looked at, she kind of zoomed in on Tony Blair's language by looking at first, what are the strong collocation between these maximizers and verbs or adjectives in speech, newspapers, parliament, and then finally in Tony Blair. And what she found is that Tony Blair, in terms of frequency, so she was not looking at it from the point of view that I'm proposing here, but in terms of frequency, Tony Blair entirely understands is part of Tony Blair's idiolect. So he uses it. The collocation between these two words is stronger in his language than anywhere else in these registers, right? But there haven't been many studies after that looked at this particular problem. And what I'm trying to do is to do more of this. And I can show you just some preliminary results from a study that two students I had for the master dissertation, Michael Cameron and Colin Murphy, conducted, as I said, for the master dissertation. So they gathered 8 participants, so a very small sample, but highly controlled because they were all academics in the humanities and all native speakers of British English, and roughly the same age. And they took them to the lab, where they gave them a questionnaire and a collocation test and a grammatical alternation test. And so this is an example from the collocation test. So you're given these 2 sentences and you have to fill in the gaps. And the gaps are generated from this corpus of academic texts. And they prompt you to select certain collocations. And similarly, the grammatical alternation test was structured in this way. So there was a gap and a selection between 2 grammatical alternations, and the context was accounted for by looking at a context where the probability of choosing one or the other is actually equal. And so the participants took this test, but importantly, they came back to the lab 2 weeks later to take the test again, even though they were told that they were going to take another questionnaire. And so what we have is now we can match pairs of texts taken by different people and pairs of texts taken by the same person, and we can see how similar they are. And for the grammatical text, the lexical material was changed as much as possible. But for the collocation test, that was not possible, of course. And these are the results. So what you see there is even though it's only 8 subjects, so it's a very small sample, the differences are very important. So you see that any individual is more similar to themselves than any other random pairing. And no 2 questionnaires are identical, right? So what we want to understand here is to what extent all of these profiles are unique. And of course, the reason why it's repeated is because we want to make sure that it's not just chance. And could it be a memory test? This is something that, of course, we wondered. And the anecdotal evidence from the debriefing points to weak memory, because the participants were asked how many sentences they remembered, and they were actually all the same. So they didn't know that. But, Michael will continue this work in his PhD. This experiment will be replicated and expanded, and we'll see what the results are very soon. But as I said, there are enough studies, and more and more is needed. Now, finally, I don't know how I'm going with time. Okay, very good. So I'll just mention another aspect, another research path, let's say, we can take that is generated by this theory, and this is the fact that it addresses the question of to what extent can we quantify an idiolect. So a fingerprint is fully quantifiable, but can an idiolect be fully quantifiable? And importantly, it comes back to the question, to the problem that we can never, the only thing we can observe in real life are texts. So we can only observe texts that belong to a particular person, I, at a particular time, T. And we know that these texts are, if we take them as sets, they are always subsets of the grammar of that particular person, that particular time. But the question is, or the hypothesis, which we subscribe to unconsciously, is the union, what I call the union hypothesis, which is the fact that if you combine, if you take the union of all of these texts at different points in time, then at some point you will approximate the active grammar of that particular person. So it must be, this is a way to frame it. It's a way to kind of uncover the assumptions, but it must be an assumption. Otherwise, we cannot do this type of work. And how can we solve this? So is it possible? Is it true? How do we find evidence for that? Well, we know that it's probably possible that we can get to solve this problem, to observe whether this is true or not, because of one of the laws of language, Herden's law or Heap's law. It's known by either of these two names, which is a law that that describes the relationship between words observed and vocabulary size. So this is the law. So the number of new words, so the V is the number of types, so the size of the vocabulary is equal to N, which is the number of word tokens, so the actual number of words that you see, to the alpha. And alpha is a parameter that has to be estimated on data, but the law says that it's a number between 0 and 1. Okay, so what that means in practice is that if you plot this relationship, you see this thing. You see this curve that grows quickly at the beginning, but then as you increase the size of N, it becomes more and more flat. Okay, so this is the same curve, and you see it at this size, and you see that it becomes very flat. So in other words, you can reframe this, you can rephrase this as there are diminishing returns the more you observe. So the more words you add, the more words are repeated, and therefore the less variety you observe over time, over word time. So for example, let's say that alpha is 0.7, which is a reasonable estimation for a language. Then these are the values that we get. So if we have 100 tokens and we observe 25 types, which is 25%, but then the more tokens we add, the diminishing the returns we get in terms of observing new words. So what this predicts is that, so this applies to variety, and it's a law that actually applies to other things outside of language as well. So the more things we add that tend to repeat, the less variety we observe. So at certain point, it will become almost inefficient to even add more data in a way. So so let's for example think about just the vocabulary. We don't know enough about the constructicon to apply this to the constructicon, but let's think about the vocabulary. So if we say that from an estimation from this paper, that a well-educated 60-year-old person active lexicon is about 50,000 words. Okay, this is an estimation that has been calculated by this team in 2016. Then the number of words that we need in order to observe that is 5 million. So it's actually a large size, but it's not something that is unfeasible. So if you think about Tony Blair's experiment, that was on 3 million words. So it is something that we can study, and of course we need a lot of data. But nowadays, thankfully, the internet allows. I mean, we write a lot, so every one of us is like Tony Blair in a way. So we can definitely collect this amount of data and begin to study and answer this question. So I'll just now conclude with some take-home messages. So the point of this talk was that assuming the main tenets of cognitive usage-based linguistics that I detailed at the beginning, then it's possible to formulate a theory of individuality using mathematical terms. Set theory, ideally one day we'll be able to use graph theory as well, when we can map out a network. And the importance of this theory is that it can guide our research efforts. So it can give, it can reveal our assumptions, and it can lead us to understand what it is that we need to research. And the goal, which is what the forensic linguist wants, but I would say probably linguistics in general should aim at, is a better understanding of linguistic individuality. Thank you very much.